So welcome everybody to the mock test run through. I'm going to start and work my way through. I'm going to start with question 1 and go through a couple of these ones. So the very first one I want to mention is question 1. Now this looks semi-easy. This looks relatively easy. We've got 37 times 99, but there is a small trick here. So I know some of you guys might have done a long multiplication. But we can spot here that 99 is very, very close to something that we can multiply by in our heads. So if we spot that this is 1 less than 100, we can multiply by 100 minus 1. And then we can use our distributive law to multiply by everything inside. So this is just equal to 3,700 minus 37 there, which we can even do in our head and get 3,663. So we need to watch out for those ones. The other one that people found difficult was this fraction one. So when we multiply mixed numbers by mixed numbers, mixed fractions, first we need to change them into improper fractions so we can multiply. So we've got here 5 1/4. So we multiply 5 by 4 to get 20, and we add the extra 1. So we have 21 quarters for the first improper fraction. And we're multiplying by, we'll do the same thing, 2 times by 7 is 14, and add the 2, so we get 16/7 there. Now, before we do any multiplying, we need to make sure that we're doing our simplifying, okay? So we can have a look and see if we can divide anything through, and I can see a factor of 7, so I can divide top and bottom by 7, giving me 1 and 3, and I can divide 4 and 16 by 4, okay, giving me 1 and 4. So our answer is simply going to be 4 times 3. So do remember to make sure you do your simplifying before you do your multiplying, otherwise it's going to get a little bit difficult when you have to simplify at the end. I think the other two were done pretty well. Next we've got number 2. Now this is just a calculation one with a little bit of bid mass. So we need to make sure we do that timesing before we do the adding. Okay, but this question was done very, very well. Right, this one was quite tricky. Which number is closest to 5.01? Now, in order to do this, we need to have a good understanding of the place values. Okay, so the first digit after the point is the 10th, and that has the highest value. And when you're comparing, you need to make sure that you're comparing digits in the same column. So for each of these ones, you can do a column subtraction to check, but I'm just going to write down the difference for each one, so we can see which one has the smallest difference and is therefore the closest. So the difference between 5.01 and 5.101 is going to be 0.09. So that will take you up to 5.1, and then the extra 1 in that thousandths digit there. The tenths, the hundredths, the thousands. So the difference is 0.091. Now, if you want to do a little subtraction, make sure you line up the decimal point so you can compare, and you're taking away digits in the same place so they have the same value. Next, the difference between 4.9 and 5.01 is 0.11. So you can see that 4.9 is just 0.1 less than 5, and add the hundredth there. Then we've got, this one's easy to spot because the difference is just 5 in that hundredths column, 0.05. This one is 0.02. So you can imagine we're 0.01, 1/100th away from 5, and then 1/100th to 1.01. And then finally, we've got 0.09 away from 5.1 there. Okay. So clearly we can see that the smallest difference is going to be D, which has just a difference of 0.02. So it is quite tricky to get our heads around the different place values. So for that one, you can just do a subtraction if you're not sure, and have some practice at comparing digits in different place values after the decimal. Now, the next one, this one was done really well. This is functions and things. So I won't go through this one. This one also was pretty good as substitution. So you can see that one container should be equal to 1, 2, 3, 4, 5, 6, 7, 8 glasses. So 2 containers should be equal to 16, but it's not. So we can do a substitution there. But that one was done really well. So I won't go through that one too much. This one I do want to go through. This is a calculation question. So I think any mistakes here are just, we need to be super careful with our multiplying and to understand the question. There are 3 different flavors of ice cream. Pip buys 4 cones of strawberry ice cream, costing $4.40 each, and 3 cones of chocolate ice cream costing $2.80 each. So I need to know how much he's spent so far. So we can work out how much he spent on strawberry ice cream. So 4 cones each cost $4.40. So we're going to do £4.40 times by 4. So we can do a multiplication just like normal and make sure we put the decimal in the right place. So 4 times 0 is 0. 4 times 4 is 16. Carry the 1. 4 times 4 is 17. And make sure that that decimal goes in 2 places before the end, because we've got 2 decimal points after the decimal place. So £17.60 was spent on strawberry ice cream. 3 cones of chocolate ice cream costed $2.80 each. So let's times together to work out how much Pip spent on chocolate ice cream. So that's going to be £2.80 times by 3. Okay, and that's going to give us 0, 4, and carry the 2. So that's going to be £8.40 there, making sure you carry over. So how much have we spent in total so far? So we're going to add those together. If you add together the pounds, you get 17 plus 8 is 25. And then if you add together the pennies, you get an extra £1. So we can add together in that way and get £26. Now, next, it's not over yet. We've got another step. He spent the same amount of money on vanilla ice cream. So let's use a different color. How many vanilla ice creams could he buy? How much did he spend if he bought 5 cones? So we need to divide that into five groups. So £26, divide that by 5. So how many 5s go into 2? None. How many 5s go into 25? We get 5. And that leaves £1. How many 5s go into £1? Well, none, but we can break it down and see how many 5p's go into 100, or kind of thinking about it in that way. How many 5s go into 100? And it's 20, but that's going to come after the decimal point there. Okay, so that's going to be £5.20 for the price of a vanilla ice cream. Okay, next one. I will go through the next one because this one was a tricky one. Write in the missing digits. So here you've got a bit of a multiplication puzzle. So 6 something 9 times by 38 needs to give me 23,900 and something. So what can we learn from here? Now, when we multiply by a 2-digit number, normally you would have 2 lines. You'd have two rows. The first one comes from 9 times by 8. We start with our 1s digit. We do 9 times by 8, which will give us 72. And the next row always starts with a 0. So our first digit can only come from the units digit of 9 times by 8. Okay, so that's going to be 72 with a carryover of 7. So that's your first step. Now we can do a little bit of maths and analysis on this, but the easiest way to solve this question is, now you've got your 1s digit, is to work backwards. So what times 38 gives me 23,902? Or in other words, 23,902 divided by 38 gives me what? Now, this is quite a difficult long division, but we already know the first digit is a 6. So I know that there's going to be 6 38s in 239. And let's check. 38 times by 6 should give me 8, carry the 4, 18 plus the 4, 228. So that works out well. And we have a remainder of 11. And then we bring down the 0 and we can see how many 38s go into 110. Okay, now I definitely can see 1 goes in. I can see 2 goes in, because that would give me 76. Can 3 go in? And we could do a quick check, but I can already see that it's not looking likely, because we've got a 4 with a carryover of 2, and that's too big. So you get your next value has to be 2 whole groups of 38 goes in, and we can actually stop there. Okay, so that's probably the easiest way you can do this. Right, good. So we've got our 2 missing digits. They were both 2 for that one. Okay, next one. Now, this is actually one that we did in class quite recently, and I will go through this because, oops, a moment. I will go through this one because there was quite a few mistakes on the surface area for this test. Now, the surface area, so it's about the area, and we know how to work out the area of things. So here, the surface area is the area of all of the surfaces in this shape. Now, little bit of a shortcut. I can spot that on the top, this is a square, which means the four faces around the outside are all of the same. And they can all be found by doing 10 times by 6, because our height is that 6 you can see on the label on the right there. That's the height, and all of the sides around the edges are 10. So I've got 4 of those faces, and then you need to think about the top and the bottom as well, which has an area of 10 times 10. And I'm going to times by 2 because I want to count that bottom face as well. So for the surface area, we just need to add these together, which gives me 6 times 4 is 24, add the 0, 240, and then 10 times 10 times 2 has got to be 200. So add those together and we get 440 square centimeters for our area, our surface area. Now, for anyone a little bit confused about me timesing by 4, normally we would just go through the 3 different directions. So we do the front and the back, which would be 10 times 6 times 2, and then we do the left and the right, which would be 10 times 6 times 2. So I was just combining that into one sum. If you can spot that, it's a square on the top. So there's 4 equal faces around the outside. And then you'd have to think about the other one we've not done, the 10 times 10, which is the top and the bottom there. So you'll still get the same answer if you do it in the way that we've learned in class, but there's a little shortcut for things that have a square base. Okay. Now, next one. Okay, I will go through this one as there was a few mistakes in this one. It was quite a tricky division, but it is more calculation here. So first, let's understand the question. The instructions for roasting a chicken are roast for 35 minutes for every kilogram and 20 minutes extra. So Bud follows these instructions and cooks for 2 hours and 12 minutes. Oops. 2 hours and 12 minutes. So because I'm dealing with minutes here, I've got 20 minutes, 35 minutes per kilogram. First, I'm going to change these into minutes because it's going to make everything much easier. So 2 hours is 120 minutes, plus our 12 is 132 minutes. Now, regardless of how much this chicken weighs, we are always going to roast for 20 minutes extra. So if I want to know the weight, I'm going to have to work backwards to find out how much. So first, let's take away the 20 minutes extra, which means that we've got 112 minutes. And that's 35 minutes for every single kilogram of chicken. So we're going to have to divide our 112 minutes into groups of 35 to decide how many kilograms we have, because for every single kilogram, we need to roast it for 35 minutes. So how many 35s in 1? None. How many 35s in 11? None. How many 35s in 112? So you will just have to try out a few things as we don't know our 35 times tables. But we can see that 2 will fit in. Will 3 fit in? So 3 times 35 gives me 90 plus 15, which is 105 there. So I can get 3 whole groups of 35, so 3 kilograms with a remainder of 7. Now, how many 35s go into 7 is none. So I need a decimal point here, which means I can now bring down a 0. So how many 35s in 70 is 2. So there's your division. So it's a bit tricky doing a division with a decimal there. But once you have a remainder, you can just bring down the 0 after the decimal point, and you can carry on the division, and you can see it's 3.2, okay, which is 3.2 kilograms. So that's equal to, this question asks for it in grams. That's equal to 3,200 grams. Now, if anyone was getting super confused by that division with the decimals, now you can get to this end point and notice you've got this remainder of 7, and 7 over 35 is just equal to 1 fifth. And you know, 1/5 of a kilogram will give you 200 grams. So that's the extra, the remainder. Okay. Right. Going well so far. Number 10. How many different ways are there to shade in one square? So the following shape has rotational symmetry of order 2. So rotational symmetry is all about spinning the shape. So how many times does it look the same in a full turn? So if it has order 2, that means when you rotate it all the way around, it will look the same twice. So you can imagine once when you've rotated it halfway, and then the same again when you rotated it all the way. For example, now, it's not a great example, but if this pen had rotational symmetry of order 2, and because it's got a funny lid and things, it doesn't, but it's going to look the same after 180 degrees, and then it will look the same after a full turn. So that's what we want. So you just need to try out some different things. There's only 2 possible places, and it's here. Oops. Here. So if you turn your head, you can see it's still going to look the same once you rotate it 180 degrees. You'll still have 3 on the left and 3 on the bottom right. And then there's one other place, which is here. So making sure that we have that same kind of shape once you rotate it. Now, for anyone wondering how we know those are all of them, you can try a few different ones out. For example, here, and you can see that when you rotate it, it's not going to look the same. Suddenly you're going to have 3 on the left, and same for all of these other places here, which aren't possible places. Okay, so that's how you can find that one. Now, what's next? Right, I will go through this one as this was a little bit tricky. This is a sequence question. So we've got a sequence of 7 numbers. So I think it helps me to kind of, when it's a small number, you can draw 1, 2, 3, 4, 5, 6, 7. So the 6th number that we have is 26. So you can see clearly that there's 3 gaps between these 3 numbers. Now, a nice way to think about that is there's always 1 less gap than number of numbers. So if you have 2 numbers, there's going to be 1 gap. So if you want to know the difference between the 6th and the 3rd, you just need to subtract them. And you can see I've got 1, 2, 3 gaps. And that makes up the difference of 26 minus 14, which is 12. So each gap or each interval has to be evenly spread because it's a rule is to add the same amount each time. So I'm going to divide it into 3 equal groups, which tells me that each time you add 4. Okay, and we can double check it. Look, 18, 22, 26, we've got it. So now we just need to find the first number. So you need to start with your 14 and you need to go back 1, 2 spaces. So we're going to do 14 minus 2 groups of 4. Okay, or you can just kind of count back. 10, 6. Okay, so that's how to do that sequence one. So to summarize, we looked at the difference between the numbers that we had, and we broke that down into how many gaps it was. So I saw that there was 12 as a difference with 3 gaps, which means our common difference is 4. And then the rest of the question is just straightforward to find the one that they want to find out. Right, this one, I'm going to skip through this one. This one was done pretty well. So this one, you can use line segments or some algebra to compare the difference between them, but this was done really well. Now, this one is a very tricky one. This is one of these work word problems where it gives you a scenario, a situation. We've got 20 cats with 5 bags of food in 3 days. And I want to know 8 cats with how many bags of food in 9 days. So starting with what we know, 20 cats eat 5 bags in 3 days. So how can I find 8 cats? So there's nothing I can divide 20 by to get 8, because 8 is not a factor of 20. But I can look for a common factor here, and I can see a common factor of 4. So if I was to divide our first line by 5, so I can find out how much 4 cats will eat. So 4 cats are going to eat, I've divided by 5, so they're going to eat 1/5 of the food, which will be just 1 bag. Because that's 1/5 of the cats, so they'll eat 1/5 of the food in the same amount of days. So now I know what 4 cats can eat, I can now quite easily work out what 8 cats will eat, because now I chose 4 because it was a common factor. So 8 is going to be a multiple of 4, which means they're going to eat double the food, 2 bags in 3 days. But this question asked me for 9 days. So I need to times everything by 3. You can imagine those same 8 cats will eat 2 bags every 3 days. So the same 8 cats will eat 2 times by 3, which is 6 bags in 9 days. Okay, so we're just going through changing one thing at a time until we get the thing that we want here. And it asks for 8 cats and 9 days. Okay. Now we also need to go through the next part, which is even trickier because you've got not many common factors here. So let's clear this and make some space so we can go again. So here we've got 3 cats, 7 bags of food in how many days? So let's start with our 20 cats and our 5 bags in 3 days. And I want to end up with 3 cats, 7 bags, and find out the number of days. Now, 20 and 3, there's nothing I can divide 20 by to get 3. So I'm going to have to do the same thing. First, I'm going to try and find out what 1 cat, how long it will take 1 cat to eat the same amount of bags. So 1 cat, so I could divide the bags and keep the days the same. But if we keep the food the same, then if I've divided the number of cats by 20, then I need to times the number of time by 20. So that will take us 60 days. So you can imagine the number of cats and the number of days have a bit of an opposite relationship. So the more cats you have, the less days you have. So if you have 20 times more cats, you need 20 times less days. If you have 20 times less cats, you need 20 times more days. Okay, and now that's special because that allows us to times by 3 and find what 3 cats can eat. So 3 cats will eat 5 bags. So now I'm going to divide those days by 3. So just find 20 days here. Okay, so I could have times the food by 3, but I know I want to get 7 bags as well. So I don't want to change these bags too much. So now we've got 3 cats eating 5 bags in 20 days. So let's try and find out. Now we need to try and get our bags to be the same. So I need to turn 5 into 7. So first we can try to find 1 bag. So 3 cats, how long will they take to eat 1 bag? So that's less food. So it's going to take them less days. So I need to divide by 5, which gives me 4 days. And now finally, I'm ready to find out the one I want, because now I just need to times by 7 to find, well, you can see here, if you look, I'll get a different pen and point it out. So this line here tells me that 3 cats will eat just 1 bag in 4 days. So the next one is the same amount of cats, 7 times the food. So I need 7 times the days. So it's 4 times by 7, which is equal to 28 days for that question. So it was really tricky, and you need to just think super carefully about the relationships between them. More cats, less days, changing one thing at a time until you can find what the question is asking you for. Okay. Right, next question. Okay, now this is a fun geometry question, really. You've got a picture, AB equals AC. So the first thing we can understand is, oopsie, if AB, so that's this line here from A to B, is equal to this one, then these are 2 sides of a triangle which have the same length. In other words, this is an isosceles triangle. And what do we know about isosceles triangles? We know that the 2 angles at the bottom are the same. Okay, these 2 are the same. So first things first, and pretty much the only thing they've told us is that EDB, so that's this one in the corner, is 16 degrees. And we can see that this one here is a right angle. So we can find our missing angle in the corner because we know angles in a triangle add up to 180 degrees. So 90, so that's this one over here, BED, plus BDE, so the 16 degrees they tell us, plus this one that I've marked. Let's mark it in a different color, this orange one here. So I'm going to mark that in orange so you can see clearly. So we normally write angles like this, and we can say ABD. So that's the angle I'm looking to work out at the moment. It needs to be equal to 180. So using a subtraction, you can find that your ABD, let's stick to orange, is equal to 180 minus 90 minus 16, which is equal to 180 minus 106, which is equal to 74 degrees. So if that orange one is equal to 74 degrees, then so is our other one on the other side of the isosceles triangle. The only reason you know that is because AB is equal to AC. So we know that's an isosceles triangle. And now you can work out this angle up the top here, ABC, because now you've got another triangle and you know two of the angles. So not AC, BAC. So the top angle on the red one is equal to 180 minus our two angles at the bottom, 74 minus 74. Now they add up to 148. So your missing angle is 32, 148, 32 degrees. And now let's mark that. We're running out of space, but the angle that they wanted to find was AFE. So that's AFE, this one. Well, now we've got one of the angles. We know this one's a right angle, so we can find the missing one. So AFE equals 180 minus 32 minus 90. And 32 minus 90 is 122. So your missing angle is 58 degrees there. So what I'm doing with that subtraction is I'm skipping a step, but I know that 180 is equal to the sum of all three of those angles, 32 plus 90 plus AFE. So I'm kind of working backwards to find the missing angle and doing that in one step. Hopefully you are following along there. Okay. Right. So that was a nice question. So using our knowledge of triangles, all angles in a triangle add up to 180 degrees. And we know right angles are 90 degrees. And just piecing together the puzzle until we get the angle that we want. Okay. Now, I will go through this one. This is one that we've taught in our classes quite recently. This was one of those cube problems. So hopefully some of you recognize what to do here. It's a wooden cube whose sides measure 11 centimeters, and he painted it all over. He then cut it up into some cubes, each of volume 1 centimeter cubes. How many of these cubes are painted on exactly 2 faces? So first things first, and for anyone that's not learned this with me or one of the other year 5 tutors before, let's understand a little bit more about a cube. Now, I'm not going to draw an 11 centimeter cube, but I will draw a basic cube. So let's imagine here we've got our cube. I'm just going to draw a 4 by 4. Keep it simple. Okay, so here's our cube. Now, which kind of faces are the ones which are going to be painted? Oh, let's carry on drawing this a little bit nicer. 1, 2. Which kind of cubes are going to be painted on exactly 2 faces? So we know that the corner pieces, okay, excuse my awful cube, but we know that the corner pieces, which are these ones, are going to be painted on 1, 2, 3 faces. We've got the front, the side, and the top. So none of the vertices are going to be counted. We know that these ones in the middle here have just 1 face painted because the rest is hiding inside the cube. We know that the ones in the center, in the core of our cube, have 0 faces painted. So the only ones we want to count are these ones along the edges. Okay, they're on every single edge. These are the type of cubes which have 2 faces painted. So we need to count them up. Now, if we think about each edge individually, the only cubes we don't want to count are the vertices. So I need to take away 2 from my 11 centimeter cube. So I'm not counting the vertices, and that gives me 9. And that's 9 are going to appear on every single edge. We've got 12 edges on a cube, 12 edges. So it's going to be 12 times 9 to get the answer for that one, which is 108 cubes. So the trick here is to recognize the type of cube. We want all of the ones that are along the edges, but not on the vertices. So then we just use the fact that we know we've got 12 edges and not counting the vertices to find the total cubes. Okay. Right, next one, I'll whiz through this one as well, because this is something we also taught recently. This is a surface area question. So we've got our 3 views that we can count, and we can add up all of the surface area from the front, the top, and the side. Now, as this is a shape, there's no blocks which are hiding our view. When you look at it from this direction, it's exactly the same as looking at it from the back. So let's count up the surface area from the front. We've got 1, 2, 3, 4, 5, 6, 7, 8. So I'm imagining I'm looking at this directly from the front, and this is the front view. That's all I will see. So you've got 8 on the front, and I mentioned it's the same on the back, so I will times that by 2. Then we can think about our left view. Okay, so from the left, well, you can see 1, 2, 3, 4, and then we've got the ones on the furthest back part, which is kind of hard to get our head around, but we've already counted 4. You've got 1 you can see on the bottom left, so that's 5, and then you've got 6, and a tiny bit there is showing you that you've got 7. You've got 7 times by 2 for that one. I'm going to rub that out so you can see for yourselves as well. So counting up the view from the left, you need to look really carefully at this row over here. You've got 1, 2, 3. That's all you're going to see. So that's 3, and you've got 4, 5, 6, 7. Okay, and we're not finished yet because we've got the top view as well, and I'm going to rub out some things you can see again. So looking at it from the top, you've got 1, 2, 3, 4, 5, 6, 7, 8. Oh, and there's one that's hiding. Can you spot it? It's this one over here, 9. So that's the top view when you look down. I'm going to rub that out so you can see it again. So I think that probably tricked out a few people not spotting these ones that are hiding in the top view, but that is going to be part of what you see from the top, just like this one is here. So that's 1, 2, 3, 4, 5, 6, 7, 8 with the extra 9 there. Okay, so working out the answer to each of those sums, well, we've got 16 plus 14 plus 18, which is equal to 48. 48, and these are edge length of 1, so there's no unit there, so we can just leave it as 48 for that one. Okay, so that's looking at the 3 views to find the surface area. So we did need to make sure that there was none of those cubes which are blocking the view, if that makes sense. So something which would stop it looking the same from the back. So that allowed us to use the trick of just doubling the front, the left, and the top view. Right, next question. Now, this question was done okay. I think I will whiz through this one as this is kind of like a nice algebra type question. 4/9 of a number is 20 less than 7/12 of the number. So if we think about 4/9 of the number, let's think about x as our number. So 4/9 of our number is going to be 4/9 times x. And I know that's 20 less than 7/12. Let's find 7/12 of our number x and take away 20. So I know these two are the same because it says 4/9 of our number, so that's this part, is 20 less. That's why I subtracted 20 from the other one of 7/12. I did 1 times and 1 not times. We don't need the times there. Okay, so now we need to solve this equation, and we've got x's on both sides. Now, the easiest way to solve this is to get rid of the fractions. So if I look for a common multiple of these things, a common multiple of 9 and 12 is 36. That's the lowest common multiple. So if I was to times everything in this equation by 36, then it works out quite nicely. Because 4/9 times 36, if I write it up here, 4/9 times 36, you're going to simplify a little bit. The 36 is going to divide by 9, and you're just going to times by 4. Okay, so we're going to When you times by 36, we get 4 times 4 on the top, which is 16x. Now that's fine as long as I times the other side by 36 as well. This is an equation, like balanced scales. So if you times 1 by 36, you times the other by 36. Now 7/12, in the same way, we're going to times by 36, but that's going to simplify a little bit. So I'm going to just times by 3. Okay, you can imagine 36 is equal to 12 times 3. So we're times by 12, and then we're times by 3, which gives us 21x. And you also need to times the 20 by 36 as well, which gives us 720. So then to simplify, you can just move your x's onto one side and move your numbers onto the other. So we get 5x is equal to 720, and therefore x must be equal to, by doing a little division, we get 144. Let's double check that. 720 divided by 5 gives me 1 remainder 2, 4 remainder 2, 4. There we go, and we've got our answer. Okay, so that's how you can solve that one with a little bit of algebra. Train timetable, I'm going to skip this one as this was done pretty well on the whole. As it's just looking through the train table and picking up the times according to the question. So I'd say make sure you read these questions really, really carefully. I'm going to skip this one. This one was done pretty well. LCM, what is the smallest number that 5, 6, 10, and 14 will all go into exactly? Now, this doesn't mention the LCM, but the smallest number that these will all go into, so it's looking for a multiple and it wants the smallest one. So we need to find the LCM. Now, a few tricks here. So if you want to find the LCM of two numbers, which are multiples of each other, like 5 and 10, then it's just going to be equal to the bigger one, because that's, of course, the smallest multiple that's a multiple of 5 as well. So we don't need to worry about 5. Now we want to find the lowest common multiple of 6, 10, and 14. So we pick the first two, we pick any two, and find the lowest common multiple of 6 and 10. Now we should know from our times tables that that's equal to 30, but we can do a little practice of our bus stop method to find the LCM, and we'll take our 6 and 10 and look for a common factor. So I've got a 2 there, which gives me 3 and 5, and then 3 and 5 have nothing in common. So my LCM just comes from 2 times 3 times 5, all the numbers around the outside, which gives me 30. And then we're almost there. We now need to find the lowest common multiple of 30 and our last number, which is 14. So maybe we'll do another bus stop method, and we'll look for common factors, of 30 and 14. And we get 2 again with 15 and 7. And then there's nothing in common between 15 and 7. So my LCM is 2 times 15 times 7, which is equal to 210 there. Okay, so that's the smallest number that they'll all go into exactly. So you're going to have to go through one by one, find the lowest common multiple of 2, and then find the lowest common multiple of that one and another one. And you can use a little trick of cancelling the 5, because that's the same as all multiples of 10. Okay. Right. Combination 1. I think this one was done pretty well. So I won't go through this one unless there's any special requests coming through. I've not seen any requests just yet. Now, 22. Right, I will mention this one because it's another LCM one. Here's one of our remainder problems. It's a 3-digit number. It can almost be divided by 5, but we've got a remainder of 3. It can almost be divided by 8, but we've got a remainder of 6. And it can be almost divided by 9, but we've got a remainder of 7. Now, they've all got different remainders, but they all have one thing in common, and that's the difference between the divisor, so when I divide by 5, and the remainder. Now, if I divide by 5, you can imagine a nice example like 12, and it has a that's not a remainder of 3, 13. So that means it's 3 greater than your last multiple of 5, but it's also 2 less than your next multiple of 5. So that difference makes up how much more you need to find the next multiple. So whilst these all have different remainders, if we were to add 2 to our number and think about our number plus 2, then suddenly I can divide by 5, I can divide by 8, and I can divide by 9. So what's the lowest common multiple of 5, 8, and 9? Well, 5 and 8 have nothing in common. So we've got an LCM of the product, which is 40. And LCM of 40 and 9 also have nothing in common, no common factors. So that LCM is just the product of those two, which is 360. Now, normally, you might just take off your 2 and find what n is, but this is asking for the maximum possible value. This is a little bit tricky. What is the maximum possible value of this number? And I know it's a 3-digit. So we need to use the trick that all common multiples are multiples of the lowest common multiple. Okay, so the next multiple, which is a multiple of all of these things, is going to be 360 times 2, which is 720. And the one after that is going to be 360 times 3, which is going to be 1080. 900 plus 180, which is too big because that's not a 3-digit number. So this is your biggest multiple, your biggest 3-digit multiple of 8, 9, and 5. But we're not quite finished because we didn't just want a multiple of those things. We wanted our number to be 2 less than that. So if n plus 2 is equal to 720, we'll take away 2 and find n is equal to 718. Okay, so that was quite a tricky one, I guess, if you didn't know the trick. But now you know to look out for these remainder tricks where you've got the same difference between that divisor and the quotient. So you can just change it a little bit and then find the LCM. Okay, this one was done pretty well. Now, I quite like these questions because we can use some line segments. Those of you that have been with me a while will remember the line segment method. So Ken weighs 5 kilograms more than Jack. Jack weighs 3 kilograms more than Robin, who in turn weighs 2 kilograms less than Lee. So Ken's being compared to Jack, but Jack's being compared to Robin, and Robin's being compared to Lee. So everyone can be compared to Robin. So if we start off by using Robin to determine our line segment, now all I'm doing by this is you could use X if you wanted to use some algebra. I'm just using a line segment to represent Robin's weight. I don't know what it is, but I don't mind just yet. Now I know that Jack weighs 3 kilograms more than Robin. So Jack can be represented using the same line segment plus a little bit, plus 3. Okay. So this first segment's the same. That represents Robin's weight, but it's 3 bigger than that. Now Ken is 5 kilograms more than Jack. So we'll take Jack's weight, and then we need to add 5. And finally, Jack weighs 3 kilograms more than Robin, who in turn weighs 2 kilograms less than Lee. So if Robin weighs 2 kilograms less than Lee, then Lee weighs 2 kilograms more than Robin. Okay, so we've got 2 extra there. And now we know that all of these add up to 125 kilograms. So we can work out that that makes up the total of 4 segments. So 4 of Robin's weights plus 3 plus 3 plus 5 plus 2, which is 13. 6, 8, 13. And that's equal to 125. So get rid of the 13 and you can find out that 4 segments, or 4 of Robin's 8, is equal to 112. And then you can just divide to find your segment must be equal to 28. Which is not quite our answer yet because it asks for Ken's weight. Now Ken is this one here, which is equal to 28 plus 3 plus 5. So you need to add together all of those, the 28 for the line segment for Robin's age and add the 3 and 5, okay? Which is going to give you 36 for your weight of Ken, okay? So that's how we can do that one for question 23. Right, almost there. We've got 10 more minutes. 24. All right, this is a cycle problem question. It's quite a complicated one because you've got a hard cycle to spot. All of the positive integers starting from 1 are filled into the rectangular number table as shown below. In which row is the number 33? So first, let's understand the cycle. It goes 1, 2, 3. Then it goes backwards, 4, 5, 6, 7, 8. Then it looks like it's gone back to the beginning, 3 numbers, 9, and then it goes backwards 2. So you can actually see that the pattern or the cycle of the positions are repeating every 2 rows like that, or every 5 numbers. So you can have a look at the next one. I'm going to go A, C, E, and then backwards, D, D, B. So in which row is number 33? So 33, if you divide that by 5, so that's the size of the group, the cycle, it repeats every 5, you get 6, remainder 3, which means you've had 6 complete cycles. So how many rows have we had if we had 6 complete cycles? Well, each cycle has 2 rows. So 6 times 2 gives me 12 complete rows. And the remainder tells me that I'm going to be in the next row. So it's going to be 12 plus 1 equals the 13th row for that one. Okay, so once you've decided that the cycle is 2 rows, we can work out that we've got 6 complete cycles, which means 12 complete rows. So the number 33 is going to be in the next one, 13. In which column is the number 72? So again, we can divide by 5 to find out how many complete cycles we've got, which gives us 14 remainder 2. Now, that tells you you've got 14 complete cycles, but now it's looking for the column I'm caring about the remainder. So after you complete a full cycle, you go back to the beginning, and a remainder of 2 will take you from A to C, the second position in the cycle, which is column C. And finally, part 3, which is probably the hardest part. What number is in the 88th row of column D? So the 88th row means we've had 86 complete rows in a cycle. So you can imagine in the 88th row, that's just about to complete a cycle. So how many complete cycles have we had? Well, it's 86 divided by 2 equals 43. And that's because every cycle has 2 rows. So you've got 43 complete cycles. Now I want to know the number. Now each cycle has 5 numbers. So you get 215 up until the end of the 43rd cycle. But we want to know in column D. So in column D, that's 1, 2, 3. That's the 4th item of the cycle, the 4th position. So you need to go 4 positions more up to 219 to find your answer for that one. So we're kind of working backwards. We're working out how many complete cycles we've got before then, what number that takes you up until, and then what position we need to be in here to count on there. And it's 4 more because we're in column D. Okay. I just had some questions. What time do we finish? So I will be finishing at 6 o'clock, at the hour. Right, almost there, 25. Now, I like this question because it's a nice simultaneous equation. So Alex, Bill, and Colin collecting seashells. Alex and Bill collect 45 shells. So we need to try and write some equations. Let's use A for Alex and B for Bill. So A plus B is equal to 45. Here I'm using A to represent the number of shells which Alex has collected and the number of shells which Bill has collected as B. B plus C, so Bill plus Colin equals 36, and Colin plus Alex equals 51. So we need to look for some way to eliminate one of these letters. Now, I'm going to describe this as equation 1, this as equation 2, and this as equation 3. So you haven't got any crossovers here, so you can't do it immediately. But if we were to take equation 1 and subtract equation 2, so starting with our left side, I've got A plus B, and then I've got taking away everything in equation 2. So I'm taking away B minus C. So I'm taking away B and I'm taking away C because I know that combined they make 36. So that's going to be equal to 45 minus 36. I'm just going to write 9 there because I've not got space, equals 9. And why have I done that? I've done that because now those B's are going to disappear. Okay, so that leaves you with A minus C. And that's going to be useful. You'll see in a minute, A minus C equals 9. That's going to be kind of like our new equation. Let's call that equation 4. Now I can combine equation 4 and equation 3, because those that have been with me in lessons can see we've got an elimination, and those that haven't can spot in one of them, I've got a C, and in the other one, I've got a minus C. And that means if you combine these equations and add them together, you can make it disappear. So 3 plus 4 is going to give me A minus C. So that's our equation 4. Let's add equation 3. So that's C plus A. And that's going to be equal to 51 plus 9. So I added together the right sides as well. If anyone confused by that, we know that A minus C is equal to 9 from our equation 4. And we know that C plus A is equal to 51 from our equation 3. So the C's simplify, and that leaves you with 2A is going to be equal to 60, which is going to let you know that A is equal to 30 there. And once you've got A is equal to 30, the rest becomes easy. So look at equation 1. A plus B is 45, so B has to be 15. And then looking at equation C3, if you like, C plus A, so C plus 30 needs to give you 51. So you get Colin has to be equal to 21 there, okay? So nice little simultaneous equations and a couple of tricks. So you can subtract one to create a new equation, which will help you to have an elimination, because we can't eliminate one of these letters directly, okay? Now, how long have we got? 4 minutes, and there's 2 questions. So I think I will spend the time on this one as the last question. Oh no, we've got a couple more questions. One more question even. I'm going to spend the time on this one because the last one was very, 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 very complicated, and not too many people had a go at that one, but I will go through it at the end if anyone wants me to. But I will spend the time on this one. 2 3-digit numbers are to be formed using the digits 0, 1, 3, 5, 6, and 8. So those in our classes might remember this from a recent lesson. What is the largest possible product of these 2 3-digit numbers? So here you've got 1, 2, 3, 4, 5, 6 digits to make 2 3-digit numbers. So if you want to get the largest possible product, well, you want to have the largest possible numbers. Now, to get the largest possible numbers, we need to think about where the hundreds, the tens, and the ones will go. So, of course, to get the largest numbers, we want our biggest digits in the biggest place. So we want the 6 and the 8 to be in our hundreds digit. Now, you can't get a bigger product by choosing smaller numbers, so we need to make sure these digits come in the hundreds column. 3 and 5 are our next biggest digits, so they can go in the tens, and 1 and 0 can go in the ones. Now, how we select these, that's going to be important in finding the biggest product. But now that we've chosen which digits go in which column, we have something which we call a fixed sum. So it doesn't matter whether you choose 3 in this one or 5 in this one. It doesn't matter if you choose 1 in this one or 0 in this one, because you will always get the same sum of 1, 8, 1, 4. But that's not important. What's important is when you have a fixed sum, the biggest product happens when the numbers are as close together as possible, if possible, a square. And if you can't remember that, you can always do a quick check. For example, the number 4. So if it's got a fixed sum, we know it's equal to 1 plus 3 and 2 plus 2. Now I know that 2 plus 2, that's going to give me the biggest product, because 2 times 2 is 4. You can see those are the ones which are close together. So how do we pick these numbers? Let's have a go. One of them is going to be a 600 and one of them is going to be an 800. Now, if I want to make these as close together as I can to make sure I get the biggest product, I'm going to use a number line to help me explain this one. So ones are going to be a 600. One's going to be an 800. So one of them somewhere in this position here, and one of them somewhere here. I don't know exactly where because I don't know what the other digits are. But if I want these to be as close together as I can, I want my 600 to be as big as I can get it, and my 800 to be as small as I can get it. So I want to squeeze these numbers closer together to try and find the biggest product. So with 600, that's the smaller one we've chosen. I need to make that as big as possible. So I'm going to choose the biggest 10, which is 5. And I'm going to choose the biggest 1, which is 1. So that's me looking at my 10s and my 1s column and choosing the biggest possible ones. And then the 800, I want to be as small as possible. So I'll choose the smaller 10 and the smaller 1s. So that gives you the biggest possible product of these numbers. Okay, so that's how we can work out how to choose the two biggest numbers and to get them as close together as possible. Right, I've seen a request for question 27. So I will go through question 27 now. It is 6 o'clock, so that's the end of the hour. So for anyone that's had all of their questions answered, feel free to leave whenever you like. I will hang around and try and finish a couple of these harder ones. And if you do have a question request that you want me to go through specifically, then you can let me know in the chat box. But otherwise, everyone feel free to leave now if you want to, or to stay for the question 27, or let me know in the chat box or anything, or you can give me a wave. I've seen a few 27s. Okay, let's have a go. Right, so I want to start off by saying, for those that have had a go at this question is very, 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 very difficult. So don't be feeling like, you know, I've got no idea how to solve this and feeling upset that you don't have any idea, because it is very tough. But I'm going to show you how you can go through it and find the answer for this one. So in the picture below, each letter represents a different digit from 0 to 9. And I want to know what the largest possible value is for, oopsie, this number here. Okay, so we've got A, B, C, D, all the way up to J. That's 10 digits. So I'm going to start off by writing down the bottom, all of the digits. So as I tick them off and I choose them, I can cross them off because I can only choose each one once. Each letter represents a different digit. So starting off, well, one thing we like to do with these addition puzzles is to look at this column here, the first column, the thousands digit. Now you can look wherever you want to start off with, but you'll find out you can't learn very much from these other digits. There's a bit of a trick here. Now G looks like it could be equal to 2. There's no carryover going on into the next column. But if you take a look at this column here, the hundreds, D plus H equals 0. Now obviously that's impossible for two different numbers to equal 0. So it must equal 10. It must be a carryover. Okay, because even if you had 9 and 8, the biggest number you can carry over is 1 there when you're adding two digits together. So that tells you what G is, because G plus our carryover gives us 2. So I know that G is equal to 1. So I'm going to cross off 1 from our list of things down the bottom. Now going to our next column, D plus H equals 10. Okay, D plus H equals 10. Now, I'm going to use that same trick as before. If you go to the next column, B plus E plus I can't be equal to 1. So we're going to have a carryover there from B plus E plus I. So let's imagine that carryover was a 1. Okay, so now D plus H plus 1 has to be equal to 10, which means that D plus H has to be equal to 9. D plus H equals 9. Now, some of you might be thinking, well, we didn't know that carryover was a 1, but we would really like it to be, because if it was a 2, then that would mean my value for H needs to be smaller for that to still be equal to 10 on the bottom. So we'd really like it if that carryover can be a 1. So let's see if it's possible. So D plus H, so is everyone happy that it's equal to 9 here? Because if it's equal to 10, including the carryover, I've just taken off that 1. I know it's got to be equal to 9. Now, if I want the original number at the bottom, the GHIJ, so that's the one, the 4 numbers going down the bottom by the line, these ones here. If I want that to be as big as possible, then I want the D to be as small as possible to make my H as big as possible. So what's the smallest I could pick for D? Well, I can't pick 0 because you can't pick a number with 0. Can see a few people showing me fingers. Very nice, Fiona, there. It's 2. That's the next one. So we've got 2 plus 7 would give me 9. Okay, so we can have our value for D. Oops. Had to rub that bit out, but I'll fix it up. So we've got 2 for D, 7 for H. And you can see that's all working out so far. So now I'm going to cross off the next 2 digits from our thing. We've used 2 and we've used 7. So now we can have a look at the next column. I do see some hands, but I'm going to try and finish this explanation first, and then I'll see if you've got questions. B plus E plus I equals 1. And we knew, well, we were hoping that would be equal to 11 with a carryover. Now, having a look at the next column, okay, A plus C plus F plus J is equal to 6. So again, we can see that that's impossible, that's going to be equal to 6. So it is going to have a carryover. Now, looking at the remaining digits, I've got a 3, a 4, a 5, a 6, an 8, and a 9. Now, these add up to 7, 12, 18, 26. 3, 7, 12, 18, 26, 35, these add up to. Now, if I had A plus C plus F plus J equals to 16, and it was just a carryover of 1, then that would mean my remaining numbers need to add up to 19 to fill out the rest of the numbers. And that's not possible for that to happen because it ends in a 1, and I'm hoping I'm going to have a carryover of 1 there. Well, it ends in a 1. So it's not going to be equal to 16, but it might be equal to 26. Okay. Now, if it was equal to 26, we would have a carryover of 2, which would mean you're carrying 2 into, carrying 2 into this tens column there. And again, using that trick, we want B plus E plus I, B plus E plus I, plus our carryover of 2 to be equal to something which ends in 1. Something 1, which we were hoping was going to be 11. Now, if we get rid of that 2, then I know that B plus E plus I has to be equal to 9. And then we can use the trick of trying to make sure that I is the biggest. So if we want I to be the biggest, then B and E need to be the smallest. So therefore, I'm going to pick, so which way round does it go? Does it matter? It does matter because I can't start BC with a 0. So I'm going to choose B as 3 and E as 0. So I've ticked off my next 2, and you can see that B plus E, so that's 3 plus 0, plus our value of 2. Oopsie, what have we done wrong here? That wasn't plus our value of 2. B plus 3 plus 0, the 2 we picked, plus our value for I has to be equal to 9, which tells you that I is the missing value of 6. So you've got 6 for your value of I there. Okay, and then we're almost there. We just need to double check that it all works out. So you've got 4, 5, 8, and 9 left, and it doesn't matter how we go because we're looking for the largest possible value along the bottom, along that one there. So how should we fit them in? Let's just double check they all add up to the right thing. So 4 plus 5 is 9, plus 8 is 17, plus 9 is 26. So we're going to want the biggest one, 9, in the bottom. And the rest, it doesn't matter how you put them. You could have 4, 5, and 8. And you can see that that does add up to 26, just as we wanted, which gives us the carryover of 2. So it looks a little bit messy because we've had to do lots of scribbles, but it looks like 1769. And you can double check it. 208, 3, 5, 4 should add up to 2016. So that's how you do that question. It's lots of analyzing of the things. It's very tricky. And, you know, this will rarely come up in an 11 plus paper. And if it does, you know, it's been picked from one of the hardest private school papers. So don't be expecting this to come up in all 11 plus papers. It was the last question and was a bit of fun, really. So I hope that you guys have followed my explanation for the analysis. I can see a few people saying bye in the chat box. Bye for those leaving. That is the end of our session today. Thank you everyone for joining. To let you all know, your tutors, well, for those of you that are students at Think Academy, your tutor will be in touch with you in the next week to send you some feedback and things. I can see I had a couple of hands. Do you want to let me know questions in the chat box? Bye, those of you going. Thank you so much for joining. Have a lovely rest of your day and see you very soon. I'm going to stop recording as well.